All right, let's look at Lenz's law in the context of the way we developed Faraday's law. So remember that we had a loop of wire and we closed that by putting a bar over it. And this wire was in a magnetic field that was, I believe, going into the page like this. So the loop was sitting comfortably in this magnetic field going into the page. But then we decided that we should exert a force so that there will be a velocity moving this bar to the right. So as we're moving the bar to the right, what happens is that we're increasing the area. So that means that the magnetic flux is increasing. So while originally the magnetic field in the loop was going into the loop, and then we're increasing the area, so we have more magnetic field into the loop. So there is an increase in magnetic field, an increase in the magnetic flux. The loop now is not comfortable with that increase, so it can induce its own magnetic field to counteract that increase. So these two directions are opposite, and the magnetic field induced in magnitude is equal to the magnitude of the change in the magnetic field. So actually not the field but the fluxes. So the magnetic flux that will be induced will be equal to the magnetic flux that caused the magnetic field to exist in the loop. So now, if we want to figure out the direction of the current that induced this magnetic field induced, we place our hand inside the loop with the fingers coming out of the page, and then the thumb will go counterclockwise, which means that through this beam, the current induced will be up. So if you go back to the motional EMF lecture, you will notice that we approached this problem from a different point of view, but we still ended up with a current going up through this beam. So you can look at this same theory from 2 points of view, either at an electron level where you're figuring out that the positive charges in the magnetic field will move counterclockwise through the loop, creating a current, or if you're looking at how the loop responds to this area of the loop being increased in the magnetic field, you will also get an induced current counterclockwise. So the same theory, but you're looking at it from 2 different points of view.